We spoke about position, x and y, of an object in only two dimensions. So we have ourselves an object. Okay, this is our object. We need to come to an agreement about how we're going to define the existence of this object. The first agreement that we have made will be that an object will be quantified in terms of kilograms. The second agreement that we have come to is that time will be defined in terms of seconds. The third agreement that we have is position will be determined in terms of meters. Each one of these have units or acronyms. I'm not quite sure how you want to think about them. I'm not quite sure the actual term. But we're going to say kilograms. This is how we're going to represent that unit. What's the example? If something is 10 kilograms, we write it as such, 10 kilograms. We have seconds. We also have meters. If we have something that's 10 seconds, we're going to write it as 10 seconds. If we have something that's 10 meters, we're going to write it as 10 meters. Now, that's great. I'm glad that you guys see that. If we can agree, can we agree? We're in agreement. Now, we talked about position in terms of distance and displacement. Okay? So, something that's a little bit more mathematical that I wanted to talk to you guys about. I think I'm going to leave that. But when you have distance and displacement, we can define new terms. Speed is defined as, or it equals to. We can assign speed, or we can assign the term speed to this ratio. That ratio is distance over time. All right? More explicit. And before that, what is distance? Remember that distance is a scalar. If distance is a scalar, that means that speed is a scalar. It actually draws its scalar nature from the fact that distance is a scalar. Time is a scalar as well. We could argue that, but we're going to consider time to be a scalar, that it's going to move in one direction only. We're not going to go in the past. We're always moving towards the future. Okay? So distance over time is speed. Now, to be a little bit more explicit, what we're really talking about the change in distance over the change, or I don't even want to say, oh no, let's see, can I go back? Well, I was writing the change. Speed is really, I erased my board accidentally, is really the change in distance. To be less ambiguous, it's the change in distance over the time that it takes you to change that distance, to go from one position to another position. Let's just call this position x final. Let's call this position x initial. All right? So it's the change in distance. This is going to be our change. So how do we represent change? We're going to represent change with a delta. Whenever you see that delta, it's going to represent change. Now, whatever follows it is going to be what's changing. In this case, the change in x over the time that it takes for us to make that change. All right? So how do we represent the change in x? Delta x is just going to equal to, let me write this, delta x over time is just going to equal to x final minus x initial over time. All right? This is our speed.